In this video, I will show you how to solve crazy rational equations like this one. But first, I'm going to show you how to solve simple equations like this one, and then we'll build from there. Baby steps. This can be factored. I'm noticing that there is a common factor of 3x. So I need to pull that out of everything. When you pull out a common factor, what you really wind up doing is dividing everything by that common factor. So I'm going to wind up dividing every term by 3x. So that is going to leave me with x to the fourth power minus 9x squared plus, what is this? Plus 14. Now, hopefully this trinomial is also factorable. Let's give it a try. So I'm going to keep my 3x out there, and I'm going to try to factor this trinomial as a binomial times a binomial. X to the fourth power will factor as x squared times x squared. Now, 14 is going to factor as 2 times 7. Inner plus outer must equal middle. Inner, I have 2x squared. Outer, I have 7x squared. I need a negative 9x squared. So I need a negative 2 and a negative 7. So if I make both of those negative, and negative 2 times negative 7 does make positive 14. So this works out. Okay, none of this can be factored any further. So it is time for the zero product property. I'm going to set each of these equal to 0. So I've got 3x equals 0. I've got x squared minus 2 equals 0. And x squared minus 7 equals 0. So I'm going to get x equals 0 from this one. Over here, so maybe I'll just put a little box around that. So I've got 0. For this one, I need to add 2 to both sides, so that'll give me x squared equals 2. And then I'm going to take the square root of both sides, so x is equal to plus or minus the square root of 2. All right, so really that's 3 solutions so far. Adding 7 to both sides gives me x squared is equal to 7. Taking the square root of both sides gives me x is equal to plus or minus the square root of 7. So there are really 5 solutions here. So that's it for number 15. All right, now let's ease our way into rational equations. And the easiest way to handle rational equations, or equations that have these fractions in them with x's in the denominator, the easiest thing to do is make the denominators all be the same. So I'm noticing that I already have x squared. So it would be great if this was also x squared. Well, that can happen if I simply multiply by x in the top and the bottom. So that's going to make this x squared, and that's going to make this 6x. All right, in fact, I think I'll just do that. So this will become 6x, and this will become x squared. So, but really, as you saw, I'm multiplying the numerator and denominator by x, which is allowed, because I'm multiplying by 1. Now the denominators are all the same. So this is where the magic happens. When all the denominators are the same throughout the equation, you can basically cancel them out. So I'm going to have an equally valid equation that goes 6x minus 5 is equal to 1. All right, that will be a valid equation. So I'm going to add 5 to both sides, so that'll be 6x is equal to 6, and then I divide both sides by 6, and I get x is equal to 1. You should do a quick check and make sure that plugging this back into the equation does not give you an undefined values. But it's totally fine. You can plug in 1 and it doesn't cause any problems. So x equals 1 is the solution. That wasn't too bad. Let's move on to number 17. So each problem is getting a little bit uglier. Factoring. Okay, we need to factor all of these denominators. So I see a common factor here. The common factor is x squared. So if I take out the x squared, then I will have x squared, and then that will leave x minus 4. Here the common factor is x. If I take that out, that will leave x minus 4. This is the same as the first one, so that's again going to be x squared and x minus 4. All right, great. So, like I said before, I need all of these denominators to be the same. I notice that they all have x minus 4. They all have a factor of x minus 4. And this one has x squared, and the last one has x squared. So it would really be nice if the middle one was also x squared. I can make that happen if I just multiply the numerator and the denominator by x. That will make this into x squared. So in fact, I'll have x up here, and down here I will now have x squared. So now all of the denominators are the same. Once all the denominators are the same, you can cancel them out and you will still have a valid equation. So my brand new, very valid equation is going to come from all of the numerators. Okay, so my new equation will be 1 minus x, all right, that's 1 minus x, equals this. Okay, 4x squared minus 16x plus 12. Let us subtract 1 from both sides and also add x to both sides. That will give us 0 is equal to 4x squared minus 15x plus 11. Yep. Hopefully this is factorable because I don't feel like using the quadratic formula really. All right, fingers crossed, people. Fingers crossed. 4x squared is a little bit troublesome because this could either be 2x times 2x, or it could be 4x times 1. So if it doesn't work one way, I'll try it the other way. But I'm going to start off with 2 and 2. Now I switch over, I look at the 11. 11 can only factor one way. It's going to be 1 times 11. It's a prime number. Inner plus outer must equal the middle. Inner, I have 2x. Outer, I have 22x. I'm trying to get a middle of negative 15. There's no way to get a 15 out of this. So that means I chose wrong. Remember earlier when I said maybe it's 4x and 1x? Yep, that's what it has to be. So let's go back and do 4x and x. Okay, I might as well not put the 11 here because that's going to make 44. So you know that's not going to be it. So let's do 11 times 1. Now, inner plus outer must equal middle. Inner, I have 11x. Outer, I have 4x. I'm trying to get a middle of negative 15. I can get that if both of these are negative. That makes negative 15. So negative and negative. Also, that works out because negative 11 times negative 1 is positive 11. So Booyah! Now we can use the zero product property to set each of these factors equal to 0. So if I set 4x minus 11 equal to 0, and if I set x minus 1 equal to 0, this is going to give me 4x equals 11, which will give me x is equal to 11 over 4. And of course, this is going to give me x is equal to 1. All right, let's do a quick peek to make sure that I'm not going to have a 0 denominator. For example, the number 4 would be illegal, right? Because I have x minus 4. 4 minus 4 would make a 0. That would be illegal. But I don't have any 4 down here, so we're good. 0 itself wouldn't have worked either. But these two are fine. So those are the answers to number 17. All right, let's just do one more in this video. Okay, once again, we want the denominators to be the same. I'm only allowed to multiply. I really need to emphasize this to you guys. I can only multiply to make the denominators the same. A common mistake is to think, oh, maybe I can just add 2. All right, adding 2 to the numerator and the denominator does not keep everything the same. Multiplying by 2 in the top and the bottom is the same as multiplying by 1. And multiplying by 1 doesn't change anything. But you can't add something. That's no good. So, unfortunately, it's not going to be quite that easy. Instead, I have to treat the x minus 2 as a whole factor, all of its own. So, I see that I have x plus 2 in the first term and the last term. So I'm going to need an x plus 2 in the middle term as well. So I'm going to multiply, because all I can do is multiply. I'm going to multiply the numerator and the denominator by x plus 2. All right, now all of the denominators have x plus 2. The only difference is the middle one has x plus 2 and it has an extra x. So I need these to have an extra x as well. So that's why I'm going to multiply the numerator and the denominator by x. All right, so now they match. And I'll do the same thing here. I'm going to multiply the numerator and the denominator by x. All right, of course, this is x squared. I'll make that change on the next step. But now the denominators are the same. All denominators are x plus 2. So once the denominators are all the same, you can cross them out. So that's going to give us 2x plus, I'm going to go ahead and do the distributive property here. So I'm going to go ahead and put 3x plus 6 equals, and here I have negative x squared. Okay, this does not look so bad. So combining like terms here, I have 5x plus 6 is equal to negative x squared. Adding x squared to both sides, I have x squared plus 5x plus 6 is equal to 0. This will surely be factorable. X squared factors as x times x. 6 can factor as 2 times 3. It can also be 6 times 1, so just be careful. Inner plus outer must equal the middle. Inner, I have 2x. Outer, I have 3x. If I want to get a positive 5x, I need everything to be positive. And that makes positive 6 as well, so this is the way to go. Notice that, okay, let me set this up again. X squared plus 5x plus 6. Notice that it would not have worked to go for 1 times 6. even though I can get a 5 out of this, inner is 1x, outer is 6x. The only way to get a positive 5 is with a negative 1 and a positive 6. Negative 1, positive 6. The problem is that negative 1 times positive 6 is negative 6, not positive 6. That's why this does not work. Common mistake alert. So all we have to do is do our zero product property. Be careful. I feel an extraneous value coming up. So we have x plus 2 equals 0, and we have x plus 3 is equal to 0. This will give us x equals negative 2 and x equals negative 3. One of these values is illegal. It's extraneous. One of these values would cause a 0 denominator if I plug it back in. Obviously, I'm talking about negative 2. If I put negative 2 in for x, that would give me negative 2 plus 2. That would be 0. You can't divide by 0. So, got to throw this one out. It is extraneous. Always watch out for that. So, there's only one solution, and it is x equals negative 3.